Okay guys, so the next part of this section of this lesson is to talk about end behavior. So end behavior is the direction a graph is heading vertically as the graph moves towards positive and negative infinity horizontally. So end behavior, like for example, I can just give you like a visual really fast. A parabola, what we have usually been working with, lately at least. The end behavior is this right here. The fact that as the graph is going towards this direction, negative infinity, and towards this direction, positive infinity, that it's increasing both on the left side and the right side of the origin. And how, it's kind of silly, but how I describe my end behavior is that all I say is up, up. That's not crazy. And that would be my answer on a quiz or a test, is for me to just say that my end behavior is up, up. So let's describe the key features that we've already been working with. So for this example here, what would my leading coefficient be? We know that it is the first term, so my leading coefficient is going to be 2. The degree of the polynomial is looking for my greatest exponent, so that's going to be the 6. This is in the previous example, so make sure you go back and look at those if you are totally lost as to why those answers are 2 and 6. And then number of terms, there are 1, 2, 3, 4, 5 terms. So this is a polynomial. Okay, so how do I get a better idea for what this graph looks like? There's 2 things that impact it, and that is the leading coefficient and the degree of the polynomial. So there's this chart that I use to organize end behavior, and I don't want you to memorize this chart. I want you to just understand this chart so you don't have to memorize. What this even and odd up here is describing is the degree. So if you put this in your notes, you want to label that what is even and odd is the degree. So this really goes back to that first activity you did with Desmos. So the shape of all even exponents, what kind of graph that looks like, and the shape of all graphs that have an odd exponent. And then the positive and negative refers to the leading coefficient. Anybody remember what happens if I have a negative in front of my function? So like x squared or negative x squared. What does that negative do? So hopefully you can remember, man, this is taking me a really long time, coefficient, we'll just leave it as that. A negative, let's type it, a negative is a reflection, or creates a reflection in the graph. Creates a reflection. So we need to remember that. Okay, so now, like I said, I don't want us to memorize this. I want us to understand it. So what's the most common graph that we've been dealing with that has an even exponent? X squared, right? So the shape of the x squared graph, we know, especially when this is positive, it's a parabola, right? We're pretty familiar with this one. So this is just like the one I had just done, that my end behavior is going to be up, up, and that's what I would say my end behavior whenever my exponent is even. So this could be a 4, this could be a 6, whatever, and the leading coefficient is positive, my end behavior will always be going up on the left and the right, and we say it left to right. So now let's do if this was a negative x squared. So negative x squared, we know x squared is going to give me a parabola shape, but this negative in front creates a reflection. So now I'm going like this. And this would be true for even if this was negative x to the 4th, negative x to the 6th, everything. Now I see my end behavior, exactly what those arrows are doing. I would say that my end behavior is down, down. Okay? Let's talk about odd degrees. So just like you saw in the Desmos activity, a graph of, let's say, an x cubed, that was like the first one we looked at, and especially if this is positive, it's that snaky looking shape. This curve is what all functions with an odd exponent are going to look like, just like you saw in that activity. So now my end behavior, again, we go left to right. My end behavior, we would say, is down, up. Okay, whether this was x to the 5th, x to the 7th, whatever. Now that negative, just like before, we know a negative creates a reflection, so now my graph would be going like this. Reflected, flipped it over the x-axis, upside down. Looking at my arrows, left to right, my end behavior is up, down. Okay, and that's my end behavior. Those are the answer. This is what your answer would be if I asked you to describe the end behavior. Okay, and that was why. So let's practice. Here, we're going to look at this guy right here, 2x to the 6th. I circled that first term because all I care about is the leading coefficient and the degree. Okay, so the degree is 6, tells me it's going to be the shape of a parabola. It's even. And the 2 is positive, so that means it's going to not have a reflection. My end behavior will be up, up. Awesome. I take a look at my next one. Again, that first term, especially we're already in standard form, my degree is odd, which means we're going to have that snaky shape, and it actually is an x cubed, so that's the one that we most use. My leading coefficient is negative, which means it has a reflection. So this, lots of arrows, now flips and becomes this. And this is the one I use, the graph that I use in my head to determine, okay, my end behavior is up, down. Okay? Again, I didn't memorize this chart just when I did that. I used what I knew about even and odd degrees and the negative in front of a function to figure out what it does to a graph. Thank you for watching. I hope you have learned about end behavior.